Chapter 4.7, Day 1, we're looking at inverse trig functions. We're going to evaluate and graph the inverse sine function and evaluate and graph other inverse trigonometric functions. So for inverse sine functions, recall from 1.9 that for a function to have an inverse function, it must be one-to-one. That is it must pass a horizontal line test. So notice that in this graph here that it would not pass a horizontal line test as it is. So what we need to do is restrict the domain to the interval negative pi over 2 to positive pi over 2 in order for the following properties to hold. So on the interval negative pi over 2 and pi over 2, the function y equals sine of x is increasing. On the same interval, it takes on the full range of values between -1 and +1. On the interval negative pi over 2 and pi over 2, it is a one-to-one function. So on the restricted domain, the y equals sine x has a unique inverse function called the inverse sine function, and it's written these two ways. So y equals arc sine of x, or y equals sine inverse of x. You must remember that sine inverse of x denotes the inverse sine function, and it's not really 1 over sine of x. The values of arc sine of x lie in the interval negative pi over 2 and pi over 2. So really important to remember that as we're evaluating. So the inverse sine function is defined by y equals arc sine of x if and only if sine of y equals x. So notice how these values change. Inverse functions, you change the x and y. So x is between -1 and 1, and then the y value is between negative pi over 2 and pi over 2. So that has to hold true there. And then the x values have to be between -1 and 1 for inside, and same for here. The domain of y equals arc sine of x is -1 and 1, and the range is negative pi over 2, pi over 2. So we're going to evaluate this inverse sine functions. So remember that the interval of sine we have to remember that y has to be between negative pi over 2 and pi over 2. And then the x value has to be between -1 and 1. So, and we're also looking at arc sine. So that is y equals arc sine of x. Or remember, that's also y equals sine inverse of x. They're the same thing. So we're looking at A, arc sine of -1/2. So we see that the x value is between -1 and 1. So another way to think about this is when does the angle equal -1/2? Now we have to remember that it has to be within this interval here between negative pi over 2 and pi over 2. So sine is negative, so it has to be here. So sine is -1/2 at negative pi over 6. And that's the answer. Okay, so sine inverse, when is that? √3 over 2. So again, another way to think about that is what angle equals sine of √3 over 2? Well, it's positive. Sine is positive, so it's here, and that is at pi over 3. So now we have sine inverse of 2. And so notice that this value here is not within the domain, so it's not possible. Okay, so it's not in the domain. So try these two examples. Find the exact value of each expression if possible. So I'm going to here, arc sine of 1 is pi over 2, so sine equals 1 when it's pi over 2. And then letter B, it's not possible because it's not in the domain. So let's graph the inverse trig functions. And so one way to think about that is let's just think about what would our x values be when graphing sine of x. So let's start with negative pi over 2, and then 0 and pi over 2. So what is the y value when x is 0? That is 0. At negative pi over 2, we know that that is -1, and at pi over 2, that is a positive 1. So if we graph that here, 0 and then -1 and positive 1, we get these graphs here, and then it makes this kind of a curve here. Okay, so that's the arc sine. And this is pi over 2, and this is negative pi over 2 for our y values. So for our cosine, so think about cosine of x. If we think of, let's start at 0. Cosine of 0 is 1. At pi over 2, it is 0. And then at pi, we are at negative 1. So we have 1, 0, negative 1, and then pi over 2 and pi. So here, here, and here, and it makes this kind of a curve. Then arc tangent. So let's think about those possibilities. Let's look at negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. So if this is x and this is y. So at negative pi over 2, that's 1 over 0, or that's undefined. Then negative pi over 4, we're at negative 1. At 0, tangent of 0 is 0. At pi over 4, that is positive 1. And pi over 2, that is undefined again. So if we think about pi over 2, that's undefined. Negative pi over 2 and pi over 2 here, that's also undefined. And then we have another important point at pi over 4 and negative pi over 4. And then 0 here, 0, 1, and negative 1. So it will make this graph. So notice it's just flipped over, right? Inverse graphs. So let's talk about the domain, range, and other important values for other important points for each of these trig functions. So for sine, the domain, notice that's between negative 1 and 1. Okay, those are their x values. Our range is between negative pi over 2 and pi over 2. The intercept, y-intercept, is 0, 0. Symmetry is over the origin, so therefore it is an odd function. For arc cosine, the domain is between negative 1 and positive 1. Okay, so I finished that 1 up there. So domain is 1, negative 1, 1. The range is between 0 and pi, and the y-intercept is at 0, pi over 2. For arctangent, the domain is negative infinity to infinity. We have all x values. Our range is between negative pi over 2 and pi over 2. The intercept is at 0, 0. We have horizontal asymptotes at y equals plus or minus pi over 2. And it's symmetric over the origin. And it's still an odd function. So those are just each of these graphs.